The next subtopic is about the complex fraction. Again, the complex fraction, it was already discussed in elementary and high school, but at this point is just the application of the complex fraction with respect to the rational expression. So we know that complex fraction is a quotient in which the numerator and or the denominator is a fractional expression. Certain problems in calculus require simplifying complex fractions of the type given in the next template. So the first example is we are going to simplify the complex fraction 2 over x plus 3 minus 2 over a plus 3 divided by x minus a. So in order for this to be solved, so what we need to do is just let's focus first on, let's simplify first the numerator. So at this point, what I did here is we find the LCD, the least common denominator for this one. So we know that the LCD is this is x plus 3 times a minus 3, a plus 3 I mean. And then what we need to do is just multiply the LCD to to get the our numerator is just multiply the LCD to each term. So our numerator, so if we multiply x plus 3 times a plus 3 to by times 2, the x plus 3 will be cancelled out. So the remaining would be 2 times a plus 3 minus, so if we multiply the LCD to in this term, so the remaining would be a negative 2 times x plus 3. So the a plus 3 will be cancelled. And then copy the denominator, our LCD so x plus 3 times a plus 3. So divided by x minus a. So this is the first step. After that is we need um to uh to conjugate no we need to, since this is division, let's apply the let's convert or invert the division operation into multiplication. So 2a plus 3 minus 2 times x plus 3 divided by x plus 3 times a plus 3. So to invert this operation from division to multiplication, so all we need to do, since we have operation also here 1, so if this is our numerator, this is also a fraction, so this we have also a fraction here, x minus a divided by 1. So if we are going to invert this to 1, we need to to change the operation from division to multiplication. We need to find its reciprocal for x minus a. So this is why uh, division to multiplication, instead of x plus a, x minus a, we have 1 minus x minus a. So after that is let's simplify this terms so 2a, so we have 2a, so for this one we have 2a times 6. So this is 2a plus 6 minus 2x minus 6. So 6 minus 6 is 0, so what we have is 2a minus 2x. Since we what we ask here is the simplest form, is so we need to factor out 2 and outside a minus x. So this is our numerator. And then our denominator is x plus 3 times a plus 3 times x minus a. So after, by inspection, a minus x will be cancelled, but the sign would be changed. Or if we if we change the sign for this, so if we factored, so we know that 2a minus x is just equal to negative 2x minus a, right? So they are just equal. So if our equation would be for our for the numerator, the factor form will be, instead of this, we'll put it like in this kind of expression so that the x minus a will be cancelled out. So the remaining would be 2 only, I mean negative 2, and then divided by the x plus 3 times x plus 3. So this is our final answer. The last subtopic for this rational expression is about the rational fraction rationalization. So, as stated here, some quotients that are not rational expressions contain denominators of the form a plus the square root of b or a square root of a plus the square root of b. These quotients can be simplified by multiplying the numerator and the denominator by the conjugate a minus square root of b. So the conjugate of a plus square root of b is a minus square root of b, or a the square root of a minus square root of b. So the conjugate of the square root of a plus square root of b is a the square root of a minus square root of b, respectively. So of course, if a minus square root of b appears, multiply by a plus a square root of b instead. So this is the conjugate. So here is our example. So what we need to do is to rationalize the denominator. So the given equation is 1 over square root of x plus square root of y. So to 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 simplify this kind of problem is so we need to find the conjugate or to multiply the conjugate for our denominator. So square root of x plus square root of y, its conjugate is square root of x minus square root of y divided by x square root of x minus square root of y. So the change was reversed, because if we are going to just to simplify this one, so this is just equal to 1, right? Equal to 1, because the numerator and then the denominator is just the same, so this is equal to 1. So after that is we need to multiply, applying the multiplication of rational fraction expressions. So numerator to numerator and then the denominator to denominator. So 1 times the square root of x minus square root of y. So this will be the next result. So square root of x plus square root of y times s square root of x minus square root of y. So the result would be, for these two, goes like this. So that is the square of square root of x minus the square of square root of y equals to, so this is already the final answer. So square root of x minus square root of y divided by, so if we square the square root of x, so the square root will be cancelled out and also the square. So that is why the answer will be x minus y. So this is our answer. So the last example is to rationalize the numerator. So we have here square root of x plus y minus square root of x divided by y. So what we need to do is just find the conjugate of our numerator, since this is the most complicated terms. So we have the radical sign. So this is the one that we need to simplify. So let me see. So here it is. So the square root of x plus y minus square root of x, the conjugate is square root of x y plus square root of x divided by the same square root of x plus y plus square root of x equals to, so this is, this is the application of, I think, the application of the special products. So just review the special products. So if you see the equations like this, why this became into like this, so the shortcut one is just review the special product in the previous lessons. So the same also goes like this. So if we multiply this one, so applying the special product, so what our next result is the um, square root of x plus 1 square minus the square root of x, the square of the square root of x. So here times here and then here times here. So and then after that is what the So yes, square root of x plus y squared minus square root of x squared. So we know that if there is, if we square this equation, the radical sign and then the square will be cancelled out. So what the remained term here is just the x plus y minus x. So the radicals and the square will be cancelled out, divided by the, so y times this expression equals, so for in the above in our numerator x minus x is 0, so the remaining would be y. So copy the denominator, and then y will be cancelled out. So the final answer is 1 over a square root of x plus y plus the square root of x. The topic that we will be discussing today is about rational expressions. Our main objective is to apply the laws and cancellations and simplification of rational expressions. So the main definition of there's what we call a fractional expression, in which it means it is a quotient of two algebraic expressions. As a special case, a rational expression is a quotient p over q of two polynomials p and q. The domain of p over q consists of all real numbers except those that make the denominator 0. So here is the simplification process. So a common non-zero factor is the numerator and denominator of a quotient may be cancelled. So if we have equations AD divided by BD, so it is equal to, so you need to just segregate them. So A over B times D over D. So we know that D over D, this is equal to 1. Therefore, it is equal to A over B times 1. Therefore, our final answer is A over B. So, a rational expression is simplified or reduced to lowest terms if the numerator and denominator have no common polynomial factors of positive degree and no common integral factors greater than 1. Again, it is a simplified, or its goal is to reduce to lowest terms. So, in order to understand this topic, let's try an example. So first example is we're going to simplify the rational expression 3x squared minus 5x um, minus 2 divided by x squared minus 4. So in order for this to be reduced into its lowest term is we need to factor out the numerator and also the denominator. So we know that if we are going to factor out or to find the factor for 3x squared minus 5x minus 2, we get the product of 3x plus 1 times x minus 2. And also for the factor for our denominator, x squared minus 4, this will become x plus 2 and then x minus 2. So since we have similar terms from the numerator and then the denominator, we can cancel out x minus 2. So that the remaining terms will be 3x plus 1 over x plus 2. So this will be our answer. So in our second equation, we need to simplify the rational expression, and 2 minus x minus 3x squared divided by 6x squared minus x minus 2. So our goal here again is to reduce or to find its lowest term. First, from this equation, let us going to rearrange this one into like this. So we know that in a standard form, let's start from the highest degree to the lowest degree until the constant. So we need to put the first term would be the highest degree of the variable, or with the highest exponent, which is 3x squared. So and then we factor out or the negative sign or negative 1 in the outside. So negative 3x squared, negative times 3x squared plus x minus 2. Or this is also just the same with 2 minus x minus 3x squared. So divided by also, so copy the 6x squared minus x minus 2. So now next step is to find its factors. So 3x squared minus plus x minus 2 the factors would be 3x minus 2 times x plus 2. So in order to find the factor, I think yeah, you already know how to factor these kind of expressions. So I suggest to recall your topic or knowledge about the factoring. So and then 6x squared for our denominator, 6x squared minus x minus 2, this will become 3x minus 2 times 2x plus 1. So there is a similar terms from the upper and the lower. So we need to cancel out 3x minus 2. So this will be cancelled. So the remaining terms will be x plus 1 divided by 2x plus 1. And then don't forget the sign. So we have a sign here. So don't forget the sign. So like this. So our answer would be negative x plus 1 divided by 2x plus 1. For our third equation, I mean, yes, third example rather, we're going to simplify the rational expression of x squared plus 8x plus 16 times x minus 5 divided by x squared minus 5x and then x squared minus 16. So in this kind of expression, all, there is no need to multiply all the terms, or you're going to use the distributive property that you need to multiply what from one term to another term. So in this topic, what our goal here is to simplify the expression. So since we are given here more than two rational expressions rather, or functions, or uh, equations, so what we need is just to factor each each equations. So for x squared plus 8x plus 16, we know that the factor for it is x. So x plus 4 squared, and then x minus 5 is, we just copy. So um, so here is the factor for the x squared plus 8x plus 16. So for our denominator, x squared minus 5x is just a simple factoring. So we need to move out the x to the outside. So here it is. And then remaining would be the x will remain, and also the negative 5. So for our x squared minus 16, our factor, this is x plus 4 times x plus x minus 4. So again, this term, so this is the factor 1. So x minus 5, just copy. And then the x squared minus 5, so here is the factor. And then for x squared minus 16, so here it is. So all we need to do is just cancel all the like terms from the numerator and then the denominator. So x plus 4 squared, so we have 2x plus 4 here. So we will cancel the x plus 4, and then x minus 5 also. So there is similarities. So the remaining is x plus 4 divided by x times x minus 4. Now let's talk about the products, quotients, sum, and difference of rational fractions. So, as stated here, for products, quotients, sum, and difference of rational expressions, you simply follow rules of fractions in lesson 1 in this module and follow simplifications process in this lesson. So, here is our example. First one is we're going to apply the multiplication of the rational fractions. So, our task is to multiply and simplify the rational expressions which are x squared minus 6x plus 9 divided by x squared minus 1 times 2x minus 2 divided by x plus 3. So we need to simplify these expressions using simply multiplication. So in this method, what we are going to do is, if we have a multiplication, is what is just the basic rule in multiplication like this is to multiply numerator to numerator, and then also denominator to denominator. So that is just the basic rule in multiplying the rational expression. So here it is. So what we need is just multiply x squared, so numerator to numerator. So x squared minus 6x plus 9 times 2x minus 2 divided by x squared minus 1 times x minus 4. So and then after that is we are going, so since we our goal is again in this topic is to reduce or to find its lowest term or to simplify these kind of expressions. So we know that if we're going to find the factors for x squared minus 6x plus 9, this will become we can get the factors or the roots will be x will be equal to positive 3. So if the factor would be x minus 3 times x minus 3. So this is the factor. So 2x minus 2, what we need to factor is just the coefficient 2. So this is factorable. So let's put the 2 outside and then remain the x minus 1. So here it is. And then for our denominator, we know that x squared minus 1, this could be factorable also, in which our factor is x plus 1 times x minus 1. And then also x minus 3, just copy. So after factoring all the expressions that we had in the given problem, is we need now to cancel out the similarities or the like terms from the numerator comparing to the denominator. So x minus 3, we have the same terms below, so this will be cancelled. And then also for our x minus 1, so then in the numerator, there is a remaining x minus 3 here, and also the 2 here. So this will be cancelled. So therefore, we have 2 times x minus 3. So here it is. And then for our denominator, x plus 1. So this is the only one left. So our answer for this example is 2 times x minus 3 divided by x plus 1. So for our next example is we are going to use the division, and then our goal is to divide and simplify the rational expressions, which the first expression is x plus 2 divided by 2x minus 3 divided by x squared minus 4 over 2x squared minus 3x. So again, we are going to divide first these expressions and then simplify them. So in the rules of division, so let's refresh or recall the topics in algebra. If we have a over b divided by c over d, if you're going, so I mean we know that the easiest way or the easiest method to solve this kind of problem is the method of multiplication. So if you're going to convert this kind of equation, the division into multiplication, is what you need to do is just copy the first expression, so a divided by b. If you need to change the operation from division to multiplication, you can do it and then just find its reciprocal, so d over c. So that is just how to convert the operation from division into multiplication. So again, just copy the first terms or expressions a divided by b and then change the operation, but you need the difference is just find the reciprocal or input the reciprocal of this one. So instead of c over d, what you need to do is just multiply to d over c, so the reverse or its reciprocal. So here it is. So copy x plus 2 divided by 2x minus 3, our first expression, times, so we inverted the operation from a division into multiplication, but we we invert or we reverse or find the reciprocal of these terms. Just notice it. So here it is. So the denominator will be our numerator, and then the denominator will be our, the numerator x squared minus 4 will be our denominator. So here it is. So next step is, since we already divide this equation, so all we need to do now is to find the simplified form of this problem. So I mean, next step is to find the factors for these rational expressions. So x plus 2, so just copy. So times, so 2x squared minus 3x. So if we're going to find the factor, is just we need to factor out, or in put the x outside to make it. So yes, this is factorable. So 2x minus 3. So the factor would be for this 2x squared minus 3x is x times 2x minus 3. So divided by, for our denominator we have 2x minus 3, yes, so copy. So x squared minus 4, so this is x plus 2 times x plus x minus 2. So the factor for x squared minus 4 is x plus 2 times x minus 2. So if we're going to simplify this kind of factored form for our from the given, so x plus 2 will be cancelled, and then also 2x minus 3 will be cancelled also. So the remaining would be x, and then divided by x minus 2. So this is our answer. So in our third expression or example is, we need to perform the operations and simplify, excuse me, 6 divided by x times 3x minus 2 plus 5 over 3x minus 2 minus 2 over x squared. So what this example is, uh, we there is an application of subtraction and addition. So if we're going to recall our basic algebra in elementary or even in high school, it was already discussed that when you add or divide such fractions, what we need is to find its LCD, or the least common denominator. So if we're going to find the least common denominator in these kind of expressions, we know that the LCD for this one is, or the least common denominator is x squared times 3x minus 2. So this is the LCD. And then after that is to, so we know that our least common denominator in this kind of example, in this expressions, is x squared times 3x minus 2. So in order for this to be solved, is we just need to multiply our LCD to each term. So uh, if you need to or to know the step by step or the short or the long method, so I inserted this one, but I suggest, so I'm more preferred in the shortcut method. So all we need to do, so just neglect this one. So all we need to do is just multiply again the LCD to each term. So x squared times 3x minus 2 times 6 over x, x times 3x minus 2. So if we have this equation, so let's say, so 6 times x squared times 3x minus 2. So this is 6x squared times 3x minus 2 over x times 3x minus 2. So as you can observe here, 3x minus 2 will be cancelled, and also the x. So the remaining would be 6x. So this is the 6x. So for second term, x squared times 3x minus 2. So here let's multiply. So for sure the remaining of this one is we have 5x squared. So that is the answer, 5x squared. So for the last term, so x squared times 3x minus 2. So the answer for this one, if you're going to multiply, is minus 2 times 3x minus 2, and then divided by also by our LCD. So just recall the topics or in this kind of method in just simplification of fractions. So overall, our answer would be 5x. So if we're going to simplify, so 5x squared. So 6x minus 6x will be cancelled. So kasi negative 2 times 3x is this is 6x. So 6x minus 6x is 0, and then negative 2 times negative 2 is positive 4. So the answer would for our numerator would be the simplest form for this kind of expression is 5x plus 4 divided by x squared times 3x minus 2. So this is already the simplified form.